Hello everyone, let's solve some Leetcode today. So today we have Leetcode 27, that is remove element. This problem is very similar to Leetcode 26 in which we had to remove duplicate elements from a sorted array. In this problem we have been given nums array and an integer val. Now we have to remove all occurrences of val in the nums array and we have to do it in place, so we cannot create any extra array. Now after removing all the occurrences of val from nums, the order of the elements may change. It means we don't have to preserve the order like ascending or descending or the original order. And after all this, we just have to return the number of elements in the nums array which are not equal to val. So at this point, a lot of people think that we can simply go through the nums array, we can count how many val are there in the nums array and we can simply return the count. But no, that's not how it is working actually. So the reality is that we actually have to remove the val in place in this nums array, and then we have to return the count of elements that are not equal to val, because it actually check this particular nums array in the backend, since we are actually removing elements in place here. So even though we don't return the nums array, it can still check in the backend whether we change the nums array in place or not. So we do have to remove the elements anyways. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the element which are not equal to val. We have to group all the elements which are not equal to val to the start of the array, and that length will be k. So k elements will be there which are not equal to val. The remaining elements of nums are not important, as well as the size of the nums. So it is saying that after you have grouped all the elements which are not equal to val in the starting of the nums array somehow, then the rest of the array does not matter. We will not check anything in the rest of the array. And finally, we have to return the k, the number of elements which are not equal to val. After submission, the online judge will check this particular k value. If this is correct, then it will go to the nums array and it will check whether the k element in the nums array are correct or not. It means we will have to modify the nums array to make sure the first k elements in the nums array are elements which are not equal to val. Now let us try to understand how to solve this problem. One way to solve this problem is to first of all sort it, so that we will have a sorted array, and then we can use Leetcode 26 problems solution to get all the unique elements at the starting of the array, and then we will simply remove val from this particular range and we will return the k by counting the range. But sorting the array will take order of n log n time complexity and we don't want it. We can do better. We will have two pointers, a and b. The a will be at start, b will be at end. And suppose that the val for us is equals to 2. So 2 is something that we don't want in the array. So first of all, we can check whether this particular element at a index is 2 or not. If it is 2, we will have to do something, right? But currently it is not 2. So we will simply shift a to here. Now again it is not 2. Again shift a to here. Now it is 2. Now what do we do? Well, we will definitely have to have some element here that does not equals to 2. It can be any other element from the array. So for swapping, I will check b. Is this particular b equals to the val? If it is equal to val, there is no point in swapping, right? So I will shift it here. Now the b is here and b is 4. So 4 is not equals to val. So I know that I can swap this 4 with this 2 to make sure that this particular range does not contain val. And since we know that we have swapped something, so it means that this particular element will be val. So we will anyways go ahead and shift the b to this next index. Now the next index can be val, cannot be val, that doesn't matter. We will simply decrement by 1. Now the loop will go again and we are still at this particular position. We see that okay, now this is 4. We will shift to next one. We saw it is again 2. Now we will check b. If b is val, it is not, so we can directly swap. This particular 2 will become 0. This will become 2, correct? Now again a is here, the loop will again run, the loop will see, okay, now it is 0, we will move a to here, we see 3, we don't have to do anything, we will again move here. So now at this point, we see that it is 2, we will have to swap it with something, but we see that a and b are basically the same. If I try to swap it, it won't matter, so I will simply go again. Now at this point, a will become greater than b, so we can simply stop our loop. And then we will have a new array of 0, 1, 4, 0, 3, and then we will have 2, 2 and 2. So as you can see that we have grouped these elements here that are not equals to val, and all the val elements are basically at this point. So now the a pointer right now is at here and b is here. The b came here because when a came here, we saw that okay, it is 2 and b and a are same. So for b also this will be simple 2. So we will decrement the b, try to get some other element. So in the code we will have a condition to decrement b by 1 and not swap this 3 with this 2. That we will have to deal with in code. That's a simple thing to deal with. You will be able to understand it just fine. But at this point, we have A here, B here. Now the indexes here are 0, 1, 2, 3, 4, and then 5. 5 elements are not equals to 12. What is the index of A? 5. So we can simply return A, and that will be our answer. So we have updated the array in place, and we are returning the number of elements which are not equals to 12 also. Now let us go through the code also. We will have A is equals to 0, B is equals to the ending index of the array. Then we will run a loop while A is less than or equal to B. Now if the value at current index is equals to val, we will try to figure out an element from the ending of the array that is not equal to val, and we will try to swap it with. That's why we have this while loop here. We are checking while B is greater than 0 and B is greater than A. We are trying to figure out if the nums of B, that is the element at B, is equal to val. If it is val, then we will simply decrement B by 1, and after this entire loop runs, we will have a B that is either equal to val or not equal to val. So if A and B become same, at that time only B will be equal to val. But that does not matter because we can swap the elements and then we will decrement B by 1. If B is equal to A, the entire while loop will terminate after this. Otherwise, the nums of A will have an element that is not equals to val, and we can continue with our while loop. Now in case we find an element at A index that is not equals to val, we will simply increment the A index because we don't have to do anything. Now after this entire while loop runs, we can simply return A because A is now the number of elements that are not equal to val in the array. Now let's try to run this and see what happens. So it runs in 0 milliseconds and beats 100% of the solution. You can really not trust the Leetcode compiler for these kind of things. Now let us look at the time and space complexity for this solution. Now even though we have a while loop inside of a while loop, the time complexity is order of n. Why? Because at each iteration of any while loop, we are either incrementing A or decrementing B. And once they are incremented or decremented, we are not doing it again and again. We just increment or decrement, increment or decrement. So we actually traverse the entire array only once. It's just that the outer loop is traversing it in this direction and the inner loop is traversing it in this direction from behind. But as soon as the B becomes less than A, we know that we have traversed all elements of the array, so we can simply break the loop and return. Now in terms of space complexity is order of 1, that is constant space complexity, because we are only using 2 pointers. We are not using any extra space. The space of output array is not considered in space complexity, only the space that we use to reach the solution. Now I discuss this particular solution here because I feel, in my opinion, that this particular solution is easier to understand for people, especially for beginners. But there is another way to implement the solution also. That solution is easier to write also, and I believe it is also easy to understand. This one is more easy to understand because you can understand when I'm incrementing A, for what reason I'm incrementing A, and for what reason I'm decrementing A and how. So this is the other way of implementing the solution. Here we are simply using a single while loop. We are not using the inner while loop. Now in order to understand this particular solution, I would highly urge you to take a test case and do a dry run on your own to make sure that you understand how this problem is solved properly. So yeah, like the video, subscribe the channel, and if you have some question that you would like me to target or some topic that you would like me to talk about, then just let me know in the comments. Now we will meet in the next video.